This is part 5 of section 6.3. We're going to work a couple of word problems. The main thing you need to get when you're doing word problems is a picture. If you can get the picture drawn, the problems usually are not that difficult. So let's look at this one. Two hikers, Sonia and Tony, leave the same point at the same time. Sonia walks due east at the rate of 3 miles per hour, and Tony walks 45 degrees northeast at the rate of 4.3 miles per hour. How far apart are the hikers after 3 hours? So our two hikers start in the same point. Sonia walks due east. Tony heads off at a 45-degree angle to the northeast. So Tony's going that way. That's 45 degrees. And I'm looking for how far apart they are after 3 hours. So I need to find the length of that side. I have a side, angle, side, or I will once I figure out what numbers to put here. So I can use Law of Cosines. Now to figure out the distance here and the distance here, we need to remember the formula that distance equals rate times time. So Sonia is traveling 3 miles an hour for 3 hours. So that distance would be 3 times 3. So Sonia travels 9. These are miles per hour, so miles. And then Tony, that distance, he's going 4.3 miles per hour for 3 hours. And that gives us 12.9 miles. Our distance, which we are looking for, will also be in miles. Okay, so just so we have something labeled here, I'm going to call this angle A, and that would make that side A. And it doesn't matter whether you think of this as B or C, because it's going to enter in the calculations are going to be the same no matter what. So side A is what I'm looking for. So A squared is equal to B squared plus C squared. So 12.9 squared plus 9 squared minus 2 times B times C times cosine of angle A, which is 45 degrees. Okay, so let's enter this, and we get 12.9 squared plus 9 squared minus 2 times 12.9 times 9 times cosine of 45 degrees. And we get approximately 83.21 for A squared. And that means our A value is approximately, take the square root of this value, it's approximately 9.1 miles. So after 3 hours, our hikers are approximately 9.1 miles apart. Okay, now a parallelogram has adjacent sides of 8 centimeters and 3 centimeters. If the shorter diagonal is 11 centimeters long, find the length of the longer diagonal. Okay, a parallelogram is like a rectangle, but without requiring 90-degree angles. So it looks like this. We are allowed to have 90-degree angles. A rectangle is a special case of a parallelogram, but in general, they're not 90 degrees. I'm going to label these the angles A, B, C, and D. Okay, our adjacent sides are 8 and 13. So if that's 8, with a parallelogram, this is also 8 centimeters. And this will be 13 centimeters and 13 centimeters. Okay, Something else we know about parallelograms is that your opposite angles are equal to each other. So angle B is going to equal angle D, and angle A is going to equal angle C. Now, about the diagonals. A diagonal is the distance from one corner to the other. And in general, with a parallelogram, you're going to have one short diagonal and one long diagonal. If you have the special case of having a square or a rectangle, your diagonals will be the same, but that's only special cases. And we're told that our shorter diagonal is 11 centimeters long. So the way I have it drawn here, that's going to be 11 centimeters. Now what I'm looking for is the length of my longer diagonal, which will be like that. Okay? What I'm going to do is I'm going to break this up into two triangles. My first one is going to be ABD. Okay? So this is angle A for sure. Now this angle is not all of angle B, and this angle is not all of angle D. This side is 8, this side is 13, and I know this side is 11. Okay? One other thing I know is that this angle right here is half of D. This angle right here is half of B. Good things to keep in mind. Now, the first thing I want to do here is I want to find angle A. If I can find angle A, then I can go and concentrate on my other triangle, which is going to be ADC. This is going to be 13, that's going to be 8, and that side is what I'm looking for. I'm going to need to find angle D, or this angle right here, because that's going to be part of C. In fact, this angle right here is going to be half of angle A, and this angle here is also going to be half of angle A. And I know that because the diagonal bisects your angle, and these two angles are equal. So if it cuts it in half, it's going to be the same for both of them. Okay, so let's find angle A. I do that by starting off with 11 squared is equal to 8 squared plus 13 squared minus 2 times 8 times 13 times cosine of angle A. So cosine of A is equal to 11 squared minus 8 squared minus 13 squared over negative 2 times 8 times 13. And I get 7/13. And if you find cosine inverse of that, you get approximately 57.42, so on. Okay? Now here, okay, the way I have it drawn, we could call this side, that side I'm looking for, that diagonal angle, side D. Okay? And if I can find a measurement for this angle right here, then I can use the law of cosines to find D. Well, what is half of A? Here I have A right here. I'm going to divide it by 2. So each of these two angles is approximately 28.71, so on. okay? So if I want to find angle D, that's going to be 180 minus half of A minus half of A, which is, so that's what's in here right now. So 180 minus that answer, and then minus that answer again. And you get that angle D is approximately 122.57 so on degrees. And I'm going to put that in memory so I can use the exact answer. Now I'll use the law of cosines here. We have d squared is equal to 13 squared plus 8 squared minus 2 times 13 times 8 times cosine of angle D, which I have in memory. Okay, so I have 13 squared plus 8 squared minus 2 times 13 times 8 times cosine of the angle I have in memory. And I get 345. So d squared equals 345. So our diagonal is exactly the square root of 345. Which is approximately 18.6. And all of these are in centimeters, so this is centimeters. This was supposed to be our longer diagonal, and it is larger than 11, so it does make sense.